at this point we have implemented our base model, and so we have the model from the previous video, which we called our base model. So I'm going to now save a copy of this. As I said, I want to keep my base and then keep my final so that I can go back to the base model if I need to. And in this video we're going to finish the project, or finish the model, where we implement these custom user statistics and animation components. So our model is now done. We've done some initial verification, and so now we want to implement these individual user statistic components. So we'll just implement these in order. So the first one says that we want to track the average time that it takes the pallets to go from the end of the inspection process to the arrival at the shipping area. So what I want to do, is from this point to this point, I want to know how long pallets spend in the system. So clearly what I need, this is an observational statistic, and I'm going to need to do a couple of things. First of all, I'm going to need to mark the entities when they leave inspection. So I need to record the current time on the entity, which tells me that I'm going to need an entity state. Then I'm going to have to create a tally statistic and then record those tallies when entities enter the shipping area. So let's do that. So we're going to go back, and the first thing we'll do is go to my model entity, and I'm going to define a real state, and we're going to call this finish inspection. Finish INSP. Then we go to our model and we mark that value as entities leave inspection. So before exiting, I'm going to do a state assignment where I assign model entity dot finish inspection, and I just assign that the current time. So note that that will assign the current simulation time when all entities leave inspection, because the S1, S2, and S3 are all instances of model entity. They will all have that custom state. The entities that go to recycling will have that marked value. We're just not going to use that value. So the next step is to define our tally statistic. So I go back to my model, elements, tally statistic, and let's call this TIS inspection shipping. TIS INSP SHIP. So I've just created my tally statistic, and I can go ahead and give it my time units if I want, because I know that what I'm recording is a time. I don't have to do that, but I'm going to do it. Then I'm going to go back, and then what I need to do is tally or record those observations when an entity enters shipping. Now note that we have entities being carried on vehicles, and when a vehicle enters the node, it then unloads the entities. So I'm going to implement that as follows. I'm going to go to shipping, add-on process, entered, and I'm going to create a process that says, first of all, I need to make sure that I'm not tracking for vehicles. So I'm going to say its condition base is vehicle, and I want the false branch. Along the false branch, I'm simply going to record the tally. So the tally statistic name is TIS INSP ship, and the value is time now minus model entity finish inspection. And so when an entity enters the sink, the decision is this a vehicle? So the vehicles will be ignored. When the entities enter, they'll take the false branch because it's not a vehicle, and we will then record the tally for INSP ship. And then finally we can go to our experiment. Let's go ahead and reset it, and we're going to add a response. TIS I2S for TIS, time and system inspection to sync. And we simply go to our tally, average. And my unit type, again, time, and I like to work in minutes, so we'll go ahead and specify that as minutes. And so at this point we can run, And while it's running, we can go back and try to figure out, well, what do we think this value is going to be approximately? Right? So when it comes out of inspection, it has to travel to wrapping. It then goes through wrapping and then travels to shipping. And so if we look back at our parameters here, the wrapping time takes on average 0.08 minutes, and then it travels the distance along the conveyor to wrapping, and then waits, or is wrapped, and then waits for a vehicle and travels this distance. So we can go back to our experiment, and we can see that we're getting approximately 0.63 or so minutes. We could go back to our model and try to assess, a little more tightly what our expectation is for additional verification. So, when I come out of the inspection, I have distance and speed of the conveyor, and I have distance here and then speed of my forklift. So I could spend some time trying to determine what I think that value is, and you should definitely make sure that you can do that. For this particular example that I gave in a test, the amount of time you would spend on that type of verification would depend, of course, on how much time you have left in the exam. You want to be comfortable that you're right, but we still have several other things that we'd like to implement. So the next statistic that we will implement, is the second one, which is the average number of S2 pallets on conveyors B, D, and E. So when I look at my model, I want to know over time, or instantaneously actually, how many S2 pallets are on this conveyor, plus this conveyor, plus this conveyor. And then I want to report that average value. So what I need to create is a state statistic, and then I need a model state that tracks the number, and then I need to increment and decrement that value, that state, as entities leave, enter and exit the conveyors. So let's go to definitions first, and let's go ahead and add our state. So I have a model state integer, and my integer state is going to be, let's just name this S2 on conveyors. So that's going to be my model state. Then I will add a state statistic. My state statistic is S2 on cons, since we can't duplicate names here. So S2 on cons, and what I want it to do is track S2 on conveyors. So I have a model state called S2 on conveyors, then I create a state statistic that just monitors that value, and then I can add my response, S2 on C, and it's just that state statistic on cons average. So at this point I've created my model state, I've created the corresponding state statistic, and I've created the corresponding response. And so now the final thing that I need to do is just increment and decrement the value as entities enter and leave the conveyors. So to do that, I'm going to use Addon Processes, and so I'm going to create my first add-on process, and the first thing I need to do is decide, is this S2? So is S2. I'm going to name my process so that I can keep track of it. This is going to be increment S2. So if this is an S2, I just need to increment that value that we just stored. So S2 on conveyors, S2 on conveyors plus 1. So I just simply increment the value. If this happens to be an S2 entity, I increment that value. Then I'm going to go and create a second process, and I'm going to name this one decrement S2. And I'm just going to copy these. The process is very similar, so I'm just going to copy these steps, and instead of incrementing, I'm now decrementing. So I now have an add-on process where I can increment an entity. Increment our model state as if the entity is S2, and I have one where I decrement. So the final step is to go back to our conveyors and the corresponding add-on processes for entered, I need to call increment S2, and for exited, I'm calling decrement S2. I do that for this conveyor also. Oops, not state assignment. Add-on process triggers. I'm going to increment when they're entered and decrement when they're exited. Increment, decrement, and then finally our last conveyor, add-on process triggers. I'm going to increment and I'm going to decrement. So now for the conveyors that we want, which is conveyor, this conveyor, this conveyor, and this conveyor, I use the two add-on process triggers to make sure that at any point in time our model state has the number of entities on this conveyor or this conveyor or this conveyor. And so when I can now go back, reset, and run my model. Now that the model is run, we see that our reported statistic, the average number is 3.75. And so again, when we're running, we would expect to see over the long term approximately 3.75 red entities either on this conveyor, or on this conveyor. Okay, so the next statistic we need to implement is this third one, the average time in system for S3 pallets that were rejected. So clearly what we need is another tally statistic because we are tracking time in system. And what we're going to do is simply when pallets come into recycling, we will just filter out for the S3 pallets and then only record the tally for those. So I'm going to go to my model, my definitions, and create a tally statistic. We'll call this TIS S3 reject. TIS S3 reject is our tally statistic. And note that unlike our previous tally statistic, we don't need to mark the entities because we're interested in the total time in system, and we know that Simio already tracks the creation time. So I go to my recycling, and I'm going to go to my add-on process trigger and simply filter out for my S3s. So this is S3. And if it is, I'm going to record the tally. So my tally statistic name, TIS S3 reject, and my value, time now, minus model entity, time created. Which Simio tracks automatically, and so we only want to record that for S3 entities. And so we can now go back to our experiment, add the response, TIS S3R for rejects, TIS S3 reject, average. And then let's go ahead and specify time, and of course I always want times in minutes. And so now we reset our model and we can execute. So our statistic reports an average of 1.94 minutes, and so if we go back again, we're looking for the S3 that are rejected. So they're going to be on this conveyor and this conveyor. They're going to wait in line. Our inspection utilization is around 83%, so there's going to be some queue times, some process times, and some travel times along here. And so again, you could and you should try to get a better estimate to for verification purposes to make sure that we have tracked that properly. So the next statistic that we want to do is the average hourly departure rates from the shipping area. So we don't want to do inspection failures, we just want to know the rate at which they depart the shipping area. So what we're going to do is we're just going to use the departure, the number departed from the input to shipping, and then simply divide that by our replication time. So I'm going to create a response, and we're going to call this departure rate. And our departure rate is simply going to be shipping input buffer number entered divided by time now minus run dot warm-up period. And so this will give us the total number that entered the input buffer to shipping. It's done at the end of the replication, so it's at time 40. Then we subtract off the warm-up period because the statistics are cleared at the end of the warm-up period, so we're tracking for 32 hours rather than 40. And we can now run our model. So we end the run with a departure rate of 285.664. Go back to our static model and we see that we have the arrival rate of 295. We rejected 9.35, and so our expected value is 285.65, and so again we're fairly close to what we expect, and so I would be comfortable with that value. Okay, so now we need a couple of status labels. We want the total number of rejected pallets, total number of shipped pallets as status labels, so we can simply use that same number entered property that we just used. So we'll go back to our model and go to animation, create a status label here, and we'll simply say this is recycling. Let's use the expression builder here. Input buffer, number entered. And I'm just going to copy that and paste it down here, and then change recycling to shipping. And as we run, hopefully those will then track as status labels, the values that we're looking for. So there's our first shipped. There's our second two. We had the vehicle that carried 2, had capacity of 2. 6, let it run for a little while, see if we can get a failure here. We have a relatively low failure rate. Let's speed this up just a bit. See if we can get something going here. There we go. So we're counting the failures, and we're counting. And we could fast forward to the end of the run, so it's going to run through our run time of 40 hours. And then we see the total number here. Note this is larger than what we saw in the experiment, right? The departure rate of, the number of departed, if we look for the how many we would expect, we would expect 9440 coming out of the good pallets and 299. So if we go back to our model, and instead of 300 and 1400, we see quite a bit bigger number, and the reason is because in interactive mode, it doesn't reset the statistics for the warm-up. The warm-up is exclusively for the experiment. So the final thing that we need to do is, well, let me see if I can get back here. Here we go. Create a status plot that shows the number of pallets in the system. So to do that, there are a couple of ways. I'll actually talk about 2 ways to do that. In general, what I need to do is I need to keep track of entities or pallets that are in the system. And so I'm going to create a model state. So go to Model, Definitions, State, and create an integer model state called WIP for work in process. And then I can simply increment that when a pallet arrives, decrement when pallets leave. So on my source, I can go to my state assignments, and just add state assignments for WIP equals WIP plus 1. For my S1s, I need to now do the same thing for S2s. WIP WIP plus 1. And finally, I need to do for S3 state assignments add WIP plus 1. And when they leave for recycling, I'll do my state assignments when entities enter. And this time we'll decrement. Whip -1. And for shipping, because again, we have vehicles, we already have a process that filters out entities. Remember, we have when it enters shipping, we say, is it a vehicle? We needed that for the tally, so we'll simply tack on an assign and use that to decrement whip here. So whip. So at this point, the state whip should track the instantaneous number in the system. So to create our status plot, we'll simply go create a plot. Let's name it Pallet in the system. Let's make it run over, I don't know, 5 hours seems like a reasonable time. And we simply want to track whip. And so now when we run our model, the status plot has the instantaneous number in the system as the system is run, or as the model is executing. So the second way I said I was going to do this, we could use, so I'm going to go and just copy this. We created a whip state. Let me delete this guy here. We created a whip state to track that, but because we want entities in the system, Simio actually already tracks that for me. So I could have S1 population number in system, so that's the instantaneous number of S1s in the system, plus S2 population number in system, plus S3 population number in system. And when we run our model, now we should see that these two status plots give us the exact same values. So had we known, if we knew that this S1.population.number in system gives us the instantaneous number, we can use that. Otherwise, we create our own model state and we just increment it and decrement it at the appropriate location. And so looking back at our model, or at our specification, we've now completed the entire model.